Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So today we are going to deal with chemistry questions from NEET paper 2020. It starts with question number 46. So let's start the session. The first question is from the chapter D and F block elements, and the question is the calculated spin only magnetic moment of Cr2 plus ion is. Okay. So first let's write down the electronic configuration of chromium atom. Okay. Electronic configuration of chromium atom is the electronic configuration of argon plus 3d5 4s1. Okay. So after first ionization, this 4s1 electron will be removed. Then after second ionization, one of the 3d5 electrons will be removed. That means only 4 electrons will be left here. So the electronic configuration of Cr2 plus will be the electronic configuration of argon plus 3d4. Okay. Now, how many unpaired electrons will be left? 4 unpaired electrons. Okay. That means N will be equal to 4. Okay. So, what is the formula to find the spin only magnetic moment? Spin only magnetic moment is equal to root n into n plus 2. Okay, where n is the number of unpaired electrons, which is 4 in this case. So let's put the value here. Under root 4 into 4 plus 2, that means under root 4 into 6, under root 24. So here on finding the root, we'll get 4.9 and the unit will be Bohr magneton. So which will be the correct answer? 4.9 Bohr magneton. That means option A will be the correct answer. Okay. Question number 47 is from the chapter hydrogen. Here we have to match two columns and identify the correct option. Okay. So the first one is carbon monoxide plus hydrogen gas. So this is commonly known as water gas or synthesis gas. Okay. So the correct match for A will be number 3. Now we come to the second one. It is temporary hardness of water. So what are the compounds involved in temporary hardness of water? These are the bicarbonates of magnesium and calcium. Okay. Magnesium and calcium. And these can be removed by boiling, right? On the other hand, if we talk about the permanent hardness of water, then what are the compounds involved? The compounds are chlorides or sulfates of magnesium, calcium, iron, etc. Okay, and these cannot be removed by boiling. So the correct match for B will be number 1. Okay. Now we come to the third one. It is diborane. B2H6. So the correct match for this will be number 2 because it is an electron deficient hydride. Why? Because boron belongs to group 13 of the periodic table. Okay. So all the elements belonging to group 13 will be electron deficient. Okay. I mean they will make electron deficient hydride. Okay. So group 13 elements will form electron deficient hydrides. Group 14 elements will form electron precise hydrides, and all the elements belonging to group 15 and more will have electron rich hydrides. Okay. So the correct match for C will be number 2. Then the last one is H2O2. So the correct match will be number 4, non-planar structure. Okay, I'm writing it here, H2O2. So the structure of H2O2 is non-planar and it has open book-like structure. Okay, so it is something like this, H, O, O and then again H. Okay. So which will be the correct match? Number 4. Okay. This will be the correct match. Question number 48 is from the chapter solution, and the question is the mixture which shows positive deviation from Raoult's law is. Options are benzene plus toluene, acetone plus chloroform, chloroethane plus bromoethane, and ethanol plus acetone. So the correct option is option D, that means ethanol plus acetone. Okay, so what do we mean by positive deviation? It means that the vapor pressure over the solution is more than that expected from Raoult's law. Okay, so it is more than expected. Now, how does this happen? Suppose we have a container and it consists of ethanol. Okay, and these are the ethanol molecules. Ethanol molecules. And we know that the ethanol molecules consist of hydrogen bonds. Okay, so these are hydrogen bonded. Now when acetone is added in it, some of the acetone molecules get in between the ethanol molecules. Okay, so this triangle shaped are acetone molecules. So let's write it down. Okay, acetone molecules get in between the ethanol molecules. Then what will happen? The hydrogen bonds of the ethanol molecules get broken. Okay. Due to this, the intermolecular forces of attraction will be weakened, right? Force of attraction weaken, and due to this it becomes easy for the ethanol molecules to escape from the solution. Okay, so ethanol molecules start escaping in the form of vapor, right? And due to this, the vapor pressure increases, okay, to the amount that is more than expected from the Raoult's law. Okay, so option D is the correct. Question number 49 is from the chapter General Principles and Processes of Isolation of Elements, and the question is identify the correct statement from the following. So the first statement is blister copper has blistered appearance due to the evolution of carbon dioxide. So this is an incorrect option because the blistered appearance of the solidified copper is due to the evolution of sulfur dioxide, not carbon dioxide. Okay. Now let's move to the second statement. It says vapor phase refining is carried out for nickel by Van Arkel method. Again, this is an incorrect option because Van Arkel method is used to refine two metals. First one is zirconium and the second one is titanium. Okay, so nickel is not the correct option. Now we come to the third statement. It says pig iron can be molded into a variety of shapes. Yes, this is a correct statement. Okay. The iron that is obtained from blast furnace consists of about 4% carbon and many impurities such as sulfur, phosphorus, silicon, manganese, etc. in smaller amount, and it can be molded into a variety of shapes. Okay. So this is a correct statement. Now what does the last statement say? It says wrought iron is impure iron with 4% carbon content. So is this a correct statement? No, this is also an incorrect statement. It does not contain 4% carbon. It consists of only less than 0.10% of carbon. Okay. And what else it contains? It contains less than 0.25% of impurities of total sulfur, phosphorus, silicon and manganese. Also, it consists of less than 2% slag by weight. Okay. So I hope you understood this question. Question number 50 is related to coordination compound, and the question is urea reacts with water to form A, which will decompose to form B. B when passed through copper ion in aqueous phase, that means aqueous copper solution, then deep blue color solution C is formed. What is the formula of C from the following? Okay, so let's see how the reaction takes place. First we have urea, that means NH2CO NH2. Okay, so this will react with water. What will we get here? We'll get ammonia water plus carbon dioxide. Okay, so this ammonia water is the compound A. Now this will decompose to give some compound. So when this ammonia water will decompose, we'll get ammonia plus water. So this ammonia is the compound B. Now this B will pass through aqueous copper. Okay, so let's write this reaction separately. Ammonia will pass through copper. Then what will we get here? We'll get CuNH3 2 plus, and this is tetraamine copper 2 cation. Okay, and this will give you a deep blue color solution. Okay, this is deep blue in color. So out of the given options, which option will be correct? Option A will be the correct answer. Question number 51 is from the chapter Equilibrium, and the question is hydrolysis of sucrose is given by the following reaction. Okay, so sucrose is getting hydrolyzed and we are getting glucose plus fructose. Then if the equilibrium constant Kc is 2 into 10 to the power 13 at 300 Kelvin, the value of delta G naught at the same temperature will be. Okay, so we have to find out delta G naught. Now we know that delta G is equal to delta G naught plus RT ln Q. Okay, and at equilibrium what happens? Delta G becomes 0 and Q is equal to Kc, where Kc is the equilibrium constant. Okay, so if we put these values here, we'll get 0, that is delta G is 0, equals to delta G naught plus RT ln Kc, right? Now we have to find out delta G naught. So delta G naught will become equal to minus RT ln Kc, isn't it? Now we'll put the values minus. The value of R is 8.314 and the unit is joule per mole per Kelvin. Okay, then we have temperature. Temperature is given 300 Kelvin. So into 300 Kelvin into ln Kc. So Kc is also given. It is 2 into 10 to the power 13. So this will give you the delta G naught. So here we can see out of the given options, in the last option we get the same expression. So last option will be the correct answer. Question number 52 is from the chapter Organic Chemistry, and here we have to identify the incorrect match. Okay, so on the left side some common names of elements are given on the basis of atomic number, and on the right side the IUPAC official name is given. Okay, so let's see how do we name the elements on the basis of atomic number. For 0 we write nil, for 1 we write un, for 2 we write bi, for 3 we write tri, for 4 we write quad, for 5 we write pent, for 6 we write hex, for 7 we write sept, for 8 we write oct, and for 9 we write n. Okay, so let's see. The first one is un, nil, un, em. Okay, so at last we add em. Okay, em is added at last. Now, so in the first one you can see we have un, that means 1, then nil, that means 0, again un, that means 1. So the atomic number is 101 and the element with atomic number 101 is Mendelevium. So this is a correct match. Its atomic number is 101. Okay. Now the second one is Uniltrium. That means 103. Okay. And the match is Lawrencium. So this is also a correct match because the atomic number of Lawrencium is 103. Okay. Now the third one is Unilhexium. That means 106, right? So the element with the atomic number 106 is Seaborgium. So this is also a correct match. Okay. Now the last one is Unium. That means 111, right? And here it is given Darmstadtium. So this is not a correct match. Okay. The element with atomic number 111 is Roentgenium. Roentgenium. Okay. So this is not a correct match. So which option will be correct? Option C. This match is incorrect. Okay. Question number 53 is from the chapter Biomolecules, and the question is which of the following is a basic amino acid? So what do we mean by basic amino acid? See, we know that amino acids consist of both the groups, amino group as well as carboxyl group, right? Now suppose an amino acid has more number of amino group than carboxyl group, then it will be basic in nature. Whereas the amino acid in which number of carboxyl group is more than the amino group, then that will be acidic in nature. Okay. So here we are asked about the basic amino acids. So out of the given options, lysine is the example of basic amino acid. Okay. Other than lysine, histidine and arginine are also basic amino acids. Okay. Now let's have a look at the structure of lysine. NH2. Then we have 5 carbons. CH2, CH2, CH2. Then again CH2, and here we have CH, one carboxyl group and one amino group. Okay, so we have two amino groups in this, only one carboxyl group, so it will be basic in nature. Okay. Question number 54 is related to redox reaction, and the question is what is the change in oxidation number of carbon in the following reaction? So we can see that methane is reacting with chlorine to give carbon tetrachloride plus hydrogen chloride. Okay. So on the left side, the compound having carbon is methane. And then on the right side, we have carbon tetrachloride. Okay. So we'll observe these two only. Suppose the initial oxidation number of carbon was X. Then X plus, we know that the oxidation number of hydrogen is plus 1. So we have 4 hydrogen. That means 4 into 1 and the total will be 0. Okay. So X plus 4 is 0. So X will be equal to minus 4. Right. Now in the product side, we can see that if the oxidation number of carbon is Y, then Y plus, what is the oxidation number of chlorine? It is minus 1, okay, for one chlorine atom. So here we have 4 chlorine atoms. So it is 4 into minus 1, okay. That means Y minus 4 equals to 0. The total will be 0, right? So what will be the value of Y? It will be plus 4. Okay. So the change in oxidation number is minus 4 to plus 4. Okay. So option B will be the correct answer. Question number 55 is from the chapter Biomolecules, and the question is sucrose on hydrolysis gives. Okay, so when sucrose is hydrolyzed, it gives an alpha D glucose, that is a 6-membered ring, and a beta D fructose. Okay, that is a 5-membered ring. So both glucose and fructose are monosaccharides, whereas sucrose is a disaccharide. Okay. So let's have a look at the structure. First we have alpha D glucose, that is a 6-membered ring. So here we have an oxygen, then here hydrogen, hydroxyl, hydroxyl, hydrogen, then hydrogen, hydroxyl, and here we have CH2OH. Okay, then here we have a fructose, so it is a 5-membered ring. Here we have hydroxyl and then CH2OH, hydroxyl, hydrogen, hydrogen, hydroxyl, and here we have CH2OH. This side we have a hydrogen, and these are linked through a glycosidic linkage, and this linkage is known as alpha 1 beta 2 glycosidic linkage. Okay. Okay, so which option will be the correct one? The option number B will be the correct one. Okay. Question number 56 is from the chapter electrochemistry, and the question is the number of Faradays required to produce 20 grams of calcium from molten calcium chloride is. Atomic mass of calcium is 40 grams per mole. Okay, suppose calcium chloride has to be dissociated. Then what will we get? Calcium ion, Ca2 plus, and chloride ion, right? Now if we have to obtain solid calcium from this calcium ion, then how many electrons should be added to this? 2 electrons are required to cancel the 2 positive charges, right? So here we'll get solid calcium. So since 2 electrons are required to get solid calcium, so the valency factor of calcium ion is 2. Okay. Now, when the valency factor is 2, what will be the equivalent mass of calcium? We know that equivalent mass is equal to atomic mass divided by valency factor. Okay. So here atomic mass is given, it is 40 grams per mole. So 40 divided by valency factor is 2. So the equivalent mass of calcium is 20. Okay. Now with the help of equivalent mass, we can find out the number of equivalents of calcium. Okay. Number of equivalents equals to given mass divided by equivalent mass. Okay. So what is the given mass in this question? It is 20 grams of calcium. So 20 divided by equivalent mass is again 20. So 20 divided by 20 will get 1. So the number of equivalents is 1. Okay. Now from Faraday's first law, we know that the amount of substance deposited at the electrode is proportional to the amount of charge passed or electricity passed. Okay. So for one number of equivalent, the amount of charge passed will be 1 Faraday. Okay. So out of the given options, option D will be the correct answer. Question number 57 is from the chapter Thermodynamics. Here a reaction is given in which two chlorine atoms are combining to give chlorine molecule. So we have to find the correct option about delta H and delta S. Okay. So we know that in order to break a bond, energy is required. Okay. So if we have to break a chlorine molecule into chlorine atoms, then we need energy. Okay. So energy will be absorbed. That means that will be an endothermic reaction, right? On the other hand, in order to form a bond, that means if we have to combine two chlorine atoms to give chlorine molecule, then the opposite will be true. That means energy will be released. So that will be an exothermic reaction. Okay. That means delta H will be negative. Okay. For exothermic reaction, delta H is negative. And delta H is change in enthalpy. Now, here we can also see that whenever a molecule is formed, that molecule is more stable as compared to the individual atoms, right? So there will be less randomness. That means molecule will be less random. And what is the indication of randomness? Delta S. Delta S is the change in entropy, and that is an indication of randomness. So less randomness means delta S will be negative. Okay. So which option will be correct? Option C will be correct. Both change in enthalpy and change in entropy are negative. Question number 58 is from the chapter S block elements, and the question is, the following metal ion activates many enzymes, participates in the oxidation of glucose to produce ATP, and with sodium is responsible for the transmission of nerve signals. So all these three functions, that means activation of enzymes, then oxidation of glucose to produce ATP, and transmission of nerve signals along with sodium ion, is the role of potassium ion. Okay, so option C will be the correct answer. Which group does potassium belong to? Group 1 of the periodic table. That means it belongs to the alkali metals. Okay, it is an alkali metal. And what is the electronic configuration of potassium? It is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s1. Okay. Question number 59 is from the D and F block elements, and here we have to identify the incorrect statement. Okay, so the first statement says the transition metals and their compounds are known for their catalytic activity due to their ability to adopt multiple oxidation states and to form complexes. So this is absolutely true. These transition metals can adopt multiple oxidation state and form complexes. Due to that, they also act as catalyst. So this is a correct statement. Now we move to the second statement. It says interstitial compounds are those that are formed when small atoms like hydrogen, carbon or nitrogen are trapped inside the crystal lattice of the metals. Again, this is a correct statement. Suppose this is a crystal lattice. These are the atoms here. So whenever small atoms occupy interstitial spaces here, then the compound formed will be interstitial compounds. Okay. So again, this is the correct statement. Now what is the third statement? It says the oxidation states of chromium in CrO4 2- and Cr2O7 2- are not the same. So we'll have to compare the oxidation states of these two. So let's check. First we have CrO4 2-, right? Now suppose the oxidation state of chromium in this compound is X. So X plus, what is the oxidation number of oxygen? For oxygen it is -2. Okay. So here 4 oxygen atoms are there. That means -2 into 4. And 2 minus charges are there. So +2. And on adding this we'll get 0. Okay. So X plus -8 plus 2 equals to 0. That means 8x plus -6 equals to 0. So what will be the value of x? It will be equal to +6. Okay. So the oxidation state of chromium in this compound is +6. Now we'll check for Cr2O7 2-. Okay. Here we have two chromium atoms. That means we'll write 2x. Okay. Plus, what is the oxidation number of oxygen? -2. So here 7 oxygens are there. So -2 into 7 plus 2 for this charge, and the sum will be 0. So 2x, here we have -14 plus 2 equals to 0. So 2x plus -12 equals to 0. That means 2x equals to +12. So what will be the value of x? It will be +12 divided by 2. That means +6. So here we can see that the oxidation state of chromium is same in both these compounds, that is +6. But here it is given they are not same. So this is not a correct option, okay, because these are same, and that is equal to +6. Okay. So we have already got the incorrect statement here. But we'll go through the last statement as well. The last statement says Cr2 plus, whose configuration is D4, is a stronger reducing agent than Fe2 plus in water. Okay. So this is a correct statement. Why? The reason lies behind the E0 value. So E0 value for Cr3 plus to Cr2 plus is -0.41 volt, whereas E0 value for Fe3 plus to Fe2 plus is plus 0.77 volt. So here you can see for chromium it is negative, right? That means the chromium 2 plus, Cr2 plus will be easily oxidized to Cr3 plus, but Fe2 plus will not be oxidized to Fe3 plus easily. Okay, therefore Cr2 plus is a stronger reducing agent. Got it? Question number 60 is from the chapter Chemical Kinetics, and the question is, an increase in the concentration of the reactants of a reaction leads to change in, options are heat of reaction, threshold energy, collision frequency and activation energy. So the correct option is option C, that means collision frequency. What is collision frequency? It is the number of collisions per second per unit volume of the reaction mixture. Okay, so when the amount of reactants is increased, then the number of collisions will also increase. Okay, so this is the correct option, and we can also represent rate of a reaction in terms of collision frequency. It is given as ZAB into e to the power EA by RT, where ZAB is the collision frequency and A and B are the reactants. Okay. Question number 61 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is, reaction between benzaldehyde and acetophenone in presence of dilute sodium hydroxide is known as, options are Cannizaro's reaction, cross Cannizaro's reaction, cross aldol condensation and aldol condensation. Okay, so two types of reactions are mentioned here, Cannizaro and aldol. What is the difference between them? The main difference is that Cannizaro's reaction is the reaction of aldehydes which do not have an alpha hydrogen. Okay, so aldehydes not having an alpha hydrogen. Whereas in case of aldol condensation, the aldehydes or ketones should have at least one alpha hydrogen. Okay, have at least one alpha hydrogen. That means it can be more than one, but at least one alpha hydrogen should be there. Okay, so we'll check if benzaldehyde and acetophenone have alpha hydrogen or not. If alpha hydrogen will be present, then aldol reaction will take place, and if alpha hydrogen will not be present, then Cannizzaro reaction will take place. Okay, so let's draw the structures. First we are drawing benzaldehyde. So this is benzaldehyde. Then the next reactant is acetophenone. Okay, double bond O CH3. So this is acetophenone. So first we see that in acetophenone, this is the carbonyl carbon, right? So the carbon next to the carbonyl carbon will be alpha carbon, and the hydrogens attached to the alpha carbon will be alpha hydrogens. So here three alpha hydrogens are present, right? That means which reaction will take place? Aldol or Cannizzaro? Aldol will take place. Okay, because alpha hydrogens are present. Got it? Now, out of aldol and cross aldol, we have to determine which one will take place. So, aldol condensation takes place when two similar molecules react with each other. For example, if two benzaldehyde molecules will react with each other, or two acetophenone molecules will react with each other, then aldol condensation will take place. But in case of cross aldol, two different molecules react with each other. So here we have two different molecules. One is benzaldehyde, the other is acetophenone. So which one will take place? Cross aldol reaction will take place. That means option C will be the correct answer. So first we'll see what product will be obtained here. So first an intermediate will be formed. Okay. Let's draw the benzene ring first. So this is the intermediate. We'll have three carbons here. This is the carbonyl group of acetophenone. Then hydrogen, hydrogen. Then here we have hydroxy group. So this is the carbonyl carbon. This is alpha position. This is beta position, right? So we have a hydroxyl group at the beta position. Okay. then condensation will take place. That means water molecule will be removed. Then a double bond will be introduced between alpha and beta carbons. That means an alkene will be formed as a final result. Okay, so carbon, one double bond. Okay, one hydrogen attached to each carbon, and then here we have carbonyl carbon and then benzene ring again. Got it? So an alkene is the final product here. Question number 62 is from the chapter Organic Chemistry, Some Basic Principles and Techniques. And the question is, a tertiary butyl carbocation is more stable than a secondary butyl carbocation because of which of the following? Options are plus R effect of methyl groups, minus R effect of methyl groups, hyperconjugation, or minus I effect of methyl groups. So the process responsible for the stability of carbocations is hyperconjugation. That means option C will be the correct answer. Now let's have a look at the structure of these carbocations. So first I am drawing the structure of tertiary butyl carbocation. So this is tertiary butyl carbocation. Now I am drawing the structure of secondary butyl carbocation. CH3, then one CH3 this side. So this is secondary butyl carbocation. Now, how do we determine the stability? We count the number of alpha hydrogens. In the tertiary butyl carbocations, you can see that all the three carbons are directly attached to the cationic carbon. So, all the hydrogens attached to these carbons are alpha hydrogen. Okay. So, here we have 3 alpha hydrogen. Then here also we have 3 alpha hydrogen. And in this also we have 3 alpha hydrogen. So, how many total number of alpha hydrogens? 3 plus 3 plus 3. That means 9 alpha hydrogens in tertiary butyl carbocation. Now in case of secondary butyl carbocation, only 2 carbons are directly attached to the cationic carbon. So these hydrogens, that means 2 alpha hydrogen this side and 3 alpha hydrogen this side. Okay. So total number of alpha hydrogens will be 3 plus 2, that means 5 alpha hydrogen. Okay. So the number of alpha hydrogens is more in case of tertiary butyl carbocation. Therefore, the tertiary butyl carbocation will be more stable as compared to secondary butyl carbocation. Okay. So let's write it down. Number of alpha hydrogen. So for tertiary butyl carbocation, it is more than that in secondary butyl carbocation. Okay. Therefore, stability will also be in the same order. Okay. Tertiary more than secondary. Got it? Alright, now question number 63 is from the chapter Equilibrium, and the question is, find out the solubility of nickel hydroxide in 0.1 molar sodium hydroxide given that the ionic product of nickel hydroxide is 2 into 10 to the power minus 15. Okay, so suppose NaOH to be dissociated, then what will we get? Na plus ion and OH minus ion. Okay, now it is given that the concentration of NaOH is 0.1 molar. So the concentration of Na plus and OH minus ions will also be 0.1 molar each. Okay. Now nickel hydroxide. If this is to be dissociated, then what will we get? Ni2 plus ion plus 2 OH minus ion. Okay. Now here we don't know the concentration of nickel hydroxide. So let's assume it is S. Then the concentration of Ni2 plus will also be S and the concentration of OH minus will be 2S. Okay. Because here 2 moles of OH minus are there. So it will be 2S. Okay. So what will be the total concentration of OH minus ion? Total OH minus ion concentration will be equal to 0.1 here and 2S here, right? So it will be 2S plus 0.1. Now, what can be figured out from the ionic product? We can see that the ionic product is very small, 2 into 10 to the power minus 15 of nickel hydroxide. That means the dissociation of OH in nickel hydroxide will be very low. So if we look at this equation, then this 2S will be very small. So we can say it will be negligible. Okay. So this 2S plus 1 can be written as 0.1 only. 2S plus 0.1 can be written as 0.1 because 2S is negligible. Okay. Now we know what is the formula for ionic product. Ionic product is equal to the concentration of product of concentration of ions. Okay, so the concentration of Ni2 plus into the concentration of OH minus raised to the power 2, keeping in mind the stoichiometry. Okay, so the ionic product is given 2 into 10 to the power minus 15. The concentration of Ni2 plus we have assumed is S, and the concentration of OH minus are 0.1 and 0.1 to the power 2. Okay, so we can find out the value of S as 2 into 10 to the power minus 15 divided by 0.1 square. Okay, so here we'll get 2 into 10 to the power minus 13 molar. Okay, so which option will be correct? Option D will be the correct answer. Alright, now question number 64 is from the chapter Chemical Bonding and Molecular Structure, and the question is identify a molecule which does not exist. Options are lithium molecule, carbon molecule, oxygen molecule and helium molecule. Okay, so here we can use our common sense to answer this question. We know that helium is a noble gas and noble gases do not form compounds, therefore these are monoatomic, not diatomic. Okay, so helium is also a monoatomic gas, so helium molecule is not possible. Okay, but we can prove this using the molecular orbital theory as well. So let's use that molecular orbital theory. So first we'll write the electronic configuration of helium molecule. If we write the electronic configuration of helium molecule, that means He2, it will be sigma 1s2 sigma star 1s2. That means 2 electrons are there in the bonding molecular orbital and 2 electrons are in the anti-bonding molecular orbital. Okay, so we can find out the bond order. Bond order is given as half Nb minus Na. That means number of electrons in the bonding molecular orbital minus number of electrons in the anti-bonding molecular orbital. So if we put the values, half into how many electrons are there in bonding molecular orbital? 2. And how many in anti-bonding? Again 2. So if we solve this, we'll get 0. And we know that if bond order is 0, then that molecule does not exist. Okay, so this is not possible for an existing molecule. Okay, so option D will be the correct answer. Question number 65 is from the chapter Haloalkanes and Haloarenes, and the question is elimination reaction of 2-bromopentane to form pent-2-ene is. So we have to find out the correct options out of the given ones. Let's write the reaction. 2-bromopentane, that means 5 carbon atoms will be there. Methyl groups will be there at both the ends. Now if this is carbon number 1, then bromine will be attached to second carbon. Okay, because this is 2-bromopentane. Now this carbon will be known as alpha carbon. So one hydrogen will be attached to this. Now the carbon next to this will be the beta carbon and 2 hydrogens will be attached to this. So let's write it like this. Okay, and the carbon next to this will also have 2 hydrogens attached. Now this reaction will take place in the presence of a base. So this base will attack the beta position. That means this beta hydrogen will be attacked. So this bond will be moved here. Okay, forming a double bond. That means this hydrogen will be removed. So this bond will also move from here to here, breaking the carbon bromine bond. So bromine will also be removed. Okay, that means hydrogen and bromine both are removed. That means HBr is removed. Okay, so what will be formed? We will get CH3, CH, double bond, CH, CH2, CH3. Okay, this is pent-2-ene. Now let's have a look at the given options. The first one says it is a beta elimination reaction. That means something is eliminated from the beta position. So we can see that the base has attacked the beta carbon. So this beta hydrogen is removed. So yes, this is a beta elimination reaction. Second is follows Zaitsev rule. So since the alkene that is formed is more substituted, so it follows Zetsef rule. So this is also correct. Now the third one is dehydrohalogenation reaction, that means removal of hydrogen halide. So here you can see that hydrogen bromide is removed. So this is a hydrogen halide. So yes, this is also a correct statement. It's correct option. And the last one is dehydration. That means removal of water molecule. So is water molecule removed here? No. So it is not dehydration reaction. That means only A, B and C will be correct. So option D will be the correct answer. Question number 66 is from the chapter Surface Chemistry, and the question is measuring zeta potential is useful in determining which property of colloidal solution. Options are solubility, stability of the colloidal particles, size of colloidal particles and viscosity. So the correct option will be option B, that is stability of colloidal particles. So let's understand what is zeta potential. It is the potential difference between two layers of opposite charge. Okay, so potential difference between two layers, and which are the two layers? First one is the fixed layer and the other is diffused layer, layer of opposite charge. So if we have a charge here, suppose this is negative charge, so it will have a layer of charge around it that will be fixed. That means it won't be able to move. So it is known as fixed layer. Okay. And again it will have another layer that will be able to move. Here the charges will be free to move. Okay. So this is known as diffused layer. And we know that whenever charges are separated, there is a potential difference. So there will be a potential difference between this fixed and diffuse charge as well, and that will be known as zeta potential, and it is a direct measurement for the stability of the colloidal solution. Okay. Now question number 67 is from the chapter Structure of an Atom, and the question is the number of protons, neutrons and electrons in lutetium respectively are. Okay, so we have the element lutetium. 71 is the atomic number and 175 is the mass number. Okay, so we know that for an element, the number of electrons is equal to the number of protons, and both individually are equal to the atomic number. Okay, so atomic number is given as 71. That means the number of electrons will be 71 and the number of protons will also be 71. Okay, now what will be the number of neutrons? Number of neutrons is equal to mass number minus atomic number. Okay, or minus number of electrons. So mass number is given as 175 and atomic number is given as 71. So what will we get here? 104. That means there will be 104 neutrons in this. So first we have to tell proton, then neutron, then electron. That means 71, then 104, then 71. That means option D will be the correct answer. Question number 68 is from the P block elements, and the question is identify the correct statements from the following. So the first statement is carbon dioxide is used as refrigerant for ice cream and frozen food. So we know that solid carbon dioxide is also known as dry ice because it is used as a refrigerant. Okay. But here it is given that the carbon dioxide is in the gaseous phase. You can see G written in bracket. It means gaseous carbon dioxide. Okay. So we know that gaseous carbon dioxide is never used as refrigerant. Only solid carbon dioxide can be used. So this statement is an incorrect statement. Okay. Now move to the second statement. It says the structure of carbon 60 contains 12 6-carbon rings and 25 carbon rings. Again, this is incorrect. Actually, this is the opposite because there are 26 carbon rings and 12 5-carbon rings. Okay. So this is also an incorrect statement. Now we move to the third statement. It says ZSM5, a type of zeolite, is used to convert alcohols into gasoline. So yes, this is a correct statement. And the last one is carbon monoxide is colorless and odorless gas. Yes, we know that carbon monoxide does not have any odor or color. So this is also a correct statement. That means only statements C and D are correct. So option C will be the correct choice. Okay, now question number 69 is from the solid state, and the question is an element has a body centered cubic, that is BCC structure, with a cell edge of 288 picometer. The atomic radius is, so we have to find out R, and cell edge is given, that means A is given. Okay, so we know that for body centered cubic, that is BCC, root 3 into A is equal to 4 into R, where A is the edge length, okay, whereas R is the radius. So we have to find out the radius. That means R will be equal to root 3A divided by 4. Now the value of A is given, so root 3 into A, that is 288 picometer, divided by 4. So out of the given options we can see option D is the correct answer. Question number 70 is from the chapter Organic Chemistry, some basic principles and techniques. And the question is, paper chromatography is an example of, options are partition chromatography, thin layer chromatography, column chromatography, and adsorption chromatography. So the correct answer is option A, that is partition chromatography. Okay, so special type of paper known as chromatography paper is used here. Special type of paper, and that is known as chromatography paper. Now what is used in case of thin layer chromatography? Here a sheet of an inert substrate such as glass, plastic or aluminium foil can be used. Okay, so inert substrate, and these substrates need to be coated with a thin layer of adsorbent material. Okay, coated with a thin layer of adsorbent material such as silica gel. Okay, now the next is column chromatography. So what is used in case of column chromatography? Here some special types of glass or stainless steel is used. Okay, and the last one is adsorption chromatography. So the material that is used in adsorption chromatography can be glass, plastic, aluminium foil, etc. Okay, but paper is used in only one, that is partition chromatography. Okay, aluminium foil. Question number 71 is from the P block elements, and the question is, which of the following oxoacid of sulfur has oxygen-oxygen linkage? So here are the options. We'll check one by one. Okay, so the first one is sulfuric acid, that means H2SO4. So let's check the structure of sulfuric acid. This is sulfur. Here we have OH, then again an OH, then sulfur oxygen double bond, and one more double bond. Okay, so can you see any oxygen oxygen linkage here? No. So first option cannot be the correct answer. Okay, now the next one is H2S2O8, that means peroxo disulfuric acid. That means it is a combination of two sulfuric acids. Okay, so this is the first sulfuric acid, sulfur, double bond O, then one OH. Then to this side, one hydrogen is removed in bond formation. Only one O is remained, and then another O, that is part of another sulfuric acid. Okay, so sulfur, double bond O, and then one more OH. Okay, so here we can see that there is a oxygen-oxygen linkage. That means this will be the correct answer. Okay, but we'll check for others as well. Third one is H2S2O7, that is pyrosulfuric acid. So here it will be similar to the H2S2O8, but instead of two oxygen in the center, there will be only one oxygen. Okay, so let's draw the structure. OH, then this is sulfur, double bond O. This side we have an oxygen, and this oxygen is common between the two sulfuric acids. Okay, so double bond O, then H. Okay, so we can see there is no oxygen-oxygen linkage here. So this is also not the correct answer. And the last one is H2SO3. That means sulfurous acid. So the structure is something like this: sulfur, one double bond O, and then two OH. Okay, again no oxygen-oxygen linkage. So only option B is the correct answer. Question number 72 is from the chapter Chemical Kinetics, and the question is the rate constant for a first order reaction is 4.606 into 10 to the power minus 3 per second. The time required to reduce 2 grams of the reactant to zero point 0.2 gram is, that means the initial concentration is 2 grams, this is A naught, and the final concentration, that is A, is zero point 0.2 gram. Okay, we have to find out the value of T. Now let's write down the formula. The rate constant K is given as 2.303 by T log A naught, that is the initial concentration of the reactant, divided by A, that is final concentration of the reactant. So this is for first order rate equation. Okay. Now K is already given. It is 4.606 into 10 to the power minus 3 per second equals to 2.303 by T log A naught is given as 2 grams and A is given as zero point 0.2 grams. Okay. So here we'll get 10 log 10, right? So T will be equal to what? 2.303 divided by 4.606 into 10 to the power 3. So 10 to the power minus 3. So this will go up and become 10 to the power 3. Okay. Log 10, and log 10 is equal to 1. Okay. So here we'll get 10 to the power 3 divided by 2. Okay, because 2 times 2.303 is 4.606. So this is 10 to the power 3 divided by 2, and log 10 is equal to 1. Okay, so this will be equal to 10 to the power 3 divided by 2, and that will be equal to 1000 divided by 2, that means 500. Okay, and the unit will be second for time. So option B will be the correct answer. The time required is 500 seconds. Now question number 73 is from the chapter Haloalkanes and Haloarenes, and the question is which of the following alkane cannot be made in good yield by Wood's reaction? Okay, so what is Wood's reaction? Here two alkyl halides react with sodium. Okay, so one alkyl halide, this plus sodium plus another alkyl halide, in the presence of dry ether to give alkane, okay, plus sodium halide. Now if both the alkyl groups are different, suppose this is R1, this is R2, then a mixture of alkanes will be obtained. Okay, now which type of alkane will be produced in good yield? So the alkanes which are symmetrical will be obtained in good yield. Okay, so let's check which of them are symmetrical and which is not. So the first one is 2,3-dimethyl butane. So let's draw the structure. 2,3-dimethyl butane, that means 4 carbons are there. 1, 2, 3, 4, and this is CH3, this is CH3, and 2 methyl groups are there, CH3, CH3. Here we have hydrogen, hydrogen. Okay, so if we divide it into two equal parts, it can be divided, right? So both the parts are equal and same in structure. So yes, this is a symmetrical alkane and it can be produced in good yield. Okay, now the next one is N-heptane. Now heptane means there will be 7 carbons, right? 3, 4, 5, 6, 7. Now how can we divide it into two equal parts? Either this side will have 4 and this side only 3 will remain. If this side we take 4, then this side only 3 will remain. So this cannot be divided into equal parts. So this is not symmetrical. Okay, that means this will not be produced in good yield. Okay, so N-heptane will be the answer because it is asymmetrical and others are symmetrical. Okay. Why? Because even if we talk about N-butane, it has 4 carbons. Okay, so 1, 2, 3, 4. So it can easily be divided into 2 equal parts. Okay, it is also symmetrical, 2 plus 2 carbons. Similarly, for N-hexane, we can find 3 this side and 3 this side. So only N-heptane is asymmetrical. So this will not be producing good yield. So option B will be the correct answer. Question number 74 is from the p block elements, and here we have to match the given oxides with their nature. Okay, so the first one is carbon monoxide and it is neutral. That means it is neither acidic nor basic oxide. Okay, so the correct match for A will be number 2. Now, the second one is barium oxide. So, what is the nature of barium oxide? It is a basic oxide. Okay, because barium is a metal and metal oxides are basic in nature. Okay, so the correct match for B will be number 1. Now, the third one is aluminium oxide. So this is aluminium is also a metal, but this is exceptional in case that it is amphoteric. That means it shows the property of acidic oxide as well as basic oxide. Okay, so the correct match for C will be number 4. And the last one is Cl2O7. So chlorine is a non-metal and the correct match will be number 3, that is acidic. So this oxide is acidic in nature. That means the match for D will be number 3. Okay. So out of the given options, which one will be correct? Number 1 will be the correct match. So here A will be the correct answer. Question number 75 is from the chapter States of Matter, and the question is a mixture of nitrogen and argon gases in a cylinder contains 7 grams of nitrogen and 8 grams of argon. If the total pressure of the mixture of the gases in the cylinder is 27 bar, then the partial pressure of nitrogen is, okay, so P total is given as 27 bar, right? And we have to find out PN2, that means partial pressure of nitrogen. So let's find out the number of moles of each of the gases. So number of moles of nitrogen gases will be equal to given mass of nitrogen divided by molecular mass of nitrogen. Okay, so given mass is 7 grams and molecular mass of nitrogen is 28. So it will come out to be 1 by 4, that is equal to 0.25. Okay. Similarly, we can find out the number of moles of argon gas also. Given mass of argon divided by atomic mass of argon. Okay. So given mass is 8 grams and atomic mass of argon is 40. Why atomic mass? Because this is monoatomic gas. So it won't be molecular mass, it will be atomic mass. Okay. So this will come out to be 1 by 5, that means 0.20. Okay. So now we have got the number of moles of each gases. What will be the total number of moles? The number of moles of nitrogen plus number of moles of argon. Okay. So 0.25 plus 0.20, that means 0.45. Okay. Now we have to find out the partial pressure of nitrogen. So using Dalton's law of partial pressure, Dalton's law of partial pressure, we can say that the partial pressure of nitrogen gas will be equal to mole fraction of nitrogen into total pressure, that is PT. Okay, so what is mole fraction of nitrogen? It is equal to number of moles of nitrogen divided by total number of moles. So we have found out the number of moles of nitrogen as 0.25. So 0.25 divided by total number of moles, that means 0.45. Okay. So on solving this, we'll get 5 by 9. Okay. So here we'll put the value 5 by 9 into total pressure, that is 27 bar. So on solving this, it will come out to be 15 bar. Okay. So option B will be the correct answer. Now question number 76 is from the chapter hydrocarbons, and the question is an alkene on ozonolysis gives methanol as one of the product. Its structure is, okay, so ozonolysis, that means lysis or breakdown of bonds due to the reaction with ozone, right? So let's write the reaction of each one of them to see which one will be the correct answer. So let's start with the first one. Suppose this molecule reacts with ozone, that means O3. Then what will happen? the affected position will be the position where double bond is present. So this bond will be broken on both the sides. Okay. So first an intermediate will be formed like this. One oxygen this side and then two oxygens this side. Okay. So all the three oxygen atoms are attached and the side chain will remain unaffected. CH2, CH2, CH3 will be there. Okay. Now in the next step, this will react with zinc water. So we'll get the final product which will look something like this. One CHO this side and one CHO this side. So two aldehyde groups will be added. Okay. And side chain will again remain unaffected. So this is the final product here. We can see that no methanol is formed. So this is not the correct answer. Okay. Now let's move to the second one. Here, which position will be affected? This position where double bond is present. Okay. So here the bond breaking will take place. So let's perform the reaction. It reacts with ozone. We'll get the intermediate. So let's draw the intermediate here. CH2, CH. Then here three oxygen atoms. One oxygen this side, two this side, and here CH2. Okay. So this is the intermediate. Then again reaction with zinc water. And then we'll get the final product which will be this one, CH2 CHO. So one aldehyde group here and the other this side, HC double bond OH. So here we have got methanol as one of the products. Okay, so this is the correct answer, but still we'll perform the reaction of other options as well. Okay, so come to the third one. This molecule reacts with the ozone. What will happen? It will be similar to the first reaction. Here the bond will be broken at this position and two aldehyde groups will be added on both the sides. Okay, so the final product will be like this. Here one CHO, then this side one CHO. Got it? And the side chain will remain unaffected. So again no methanol is formed. So this is also not correct. And the last one will be similar to the second one. But here on this side we have two carbons. So ethanol will be formed instead of methanol. Okay. So the final product will be what? Let's see. This here CHO and then this side will have ethanol, right? So CH3CHO. So this side we have ethanol, not methanol. So the correct option is option B. Question number 77 is from the chapter solutions and the question is the freezing point depression constant, that is Kf of benzene, is 5.12 Kelvin kg per mole. The freezing point depression for the solution of molality 0.078 molal containing a non-electrolyte solute in benzene is, and the answer should be rounded off up to 2 decimal places. Okay. So it's very simple. We know that the freezing point depression, that is denoted by delta TF, is equal to Kf into M, where Kf is the freezing point depression constant and M is the molality of the solution. Okay. So Kf is given here. It is 5.12 Kelvin kg per mole into molality is also given. It is 0.078 molal. Okay. So 0.078. Now if we solve this, what will we get? 0.399 and the unit for the freezing point depression will be Kelvin. Okay, because it is a temperature. So we have to now round it off up to 2 decimal places. That means up to this place. Okay, so we can write it like this, 0.40 Kelvin, right? So which option will be correct? Option B will be the correct answer. Question number 78 is from the chapter thermodynamics and the question is the correct option for free expansion of an ideal gas under adiabatic condition is. Okay, so two things are to be noted here. First, there is free expansion of gas and then the condition is adiabatic. Okay, so we know that in adiabatic condition no heat is transferred. Okay, so no transfer of heat between the system and surrounding. Okay, between system and surrounding. That means Q will be equal to 0. Q denotes the heat. Okay. So one thing is clear that heat is 0. Now there is free expansion Free expansion means the external pressure is 0. Okay. P external is 0. So what will be the work done? Work is equal to minus P external delta V, and that is 0. Okay, because P external is 0. So work done is also 0. So Q is 0 and work done is also 0. So in which of the options Q and W both are 0? The last one. Okay. So this is the correct option. Why delta T is given as 0? Let's see. We know that from first law of thermodynamics, that delta U, that means change in internal energy, is equal to Q plus W, where Q is the heat and W is the work done. So both are 0. That means delta U will also be 0. That means internal energy is constant. Okay. Therefore, there is no change in internal energy. Got it? And also we know that internal energy is a function of temperature. So when the internal energy is constant, that means delta T is 0, because temperature is also constant. So change in temperature is also 0. Therefore, delta T is also 0. So all of them are 0. Got it? Question number 79 is from the chapter Some Basic Concepts of Chemistry, and the question is, which one of the following has maximum number of atoms? So how do we find number of atoms? If we know the number of moles, then we can find out the number of atoms as well by multiplying the number of moles of an element with Avogadro number. Okay, so Avogadro number is a constant. Okay, and number of moles is equal to given mass of the element by atomic mass. Okay, so in this case, given mass is same in all, that is 1 gram. So the number of moles will be equal to 1 by atomic mass of that element. Okay, so let's find out one by one. For the first one, that is magnesium, number of mole will be 1 by atomic mass, that is 24. It is given here. So 1 by 24. Therefore, what will be the number of atoms? Suppose N small a will be equal to number of moles, that is 124, into Avogadro number, that is Na. Okay. Similarly, for the second one, the number of mole will be 1 by 16. So the number of atoms will be 1 by 16 into Avogadro number. Okay. For the third one, number of moles will be 1 by 7. So the number of atoms will be 1 by 7 into Avogadro number. And the last one is argon with atomic mass 108. So the number of mole will be 1 by 108. So the number of atoms will be, writing here, 1 by 108 into Avogadro number. Okay. Now we have to find out the maximum number of atoms. So which one is maximum? This is 1, this is 2, this is 3, and this is 4. So the maximum is this one, 1 by 7 into Avogadro number, because if Avogadro number is same, so the quantity will depend on this. So 1 by 7 is the maximum quantity, so this will be the maximum number of atoms. Okay, so lithium will have maximum number of atoms. So option C is the correct answer. Question number 80 is from the chapter Haloalkanes and Haloarenes, and the question is, identify compound X in the following sequence of reaction. So we can see here that the reactant is methyl benzene. It is reacting with chlorine in the presence of sunlight. Then we are getting an intermediate X, which on hydrolysis is giving an aldehyde as a product. Okay, so since a halogen is being added in the presence of sunlight, so free radical halogenation will take place. Okay, free radical halogenation reaction will take place. Now let's see what happens. So this is our reactant, methyl benzene. Okay, now it is reacting with chlorine in the presence of sunlight. So this chlorine molecule, that means two chlorine atoms, will replace two hydrogens from here. So what will we get? This is the benzene ring. So two hydrogens will be replaced. That means one will remain there and two chlorine atoms will be added here. Okay, so CHCl2, and this is the intermediate X. Okay, so option B will be the correct answer. Now let's complete this reaction. This will undergo hydrolysis. So reaction with water molecule at 373 Kelvin. Then what will happen? Again, these two chlorine atoms will be replaced by OH. Okay, so what will we get here? This is the benzene. Here what will we get? CH, and then 2 OH will be added in place of 2 chlorine atoms. Okay, and then dehydration will take place. That means water will be removed, and then that means 2 hydrogen and 1 oxygen will be removed. So 2 hydrogens and 1 oxygen will be removed. What will be left here? CHO will be left. Therefore an aldehyde is formed as a final product. Okay, so I hope you understood this. Now question number 81 is from the chapter coordination compounds, and the question is, which of the following is the correct order of increasing field strength of ligands to form coordination compounds? Okay, so for that we can keep in mind the spectrochemical series. Spectrochemical series. So what is spectrochemical series? It is a series of ligands that is mentioned in a particular order of field strength. Okay, so let's write it down here. Iodide, then bromide, then SCN minus, that is thiocyanide, then S2 minus, then F minus, then OH minus, then C2H4 2 minus, then water. Then I'm writing here NCS minus, then EDTA 4 minus, that is ethylene diamine tetraacetate, then ammonia, then En, then Cn minus cyanide, then carbon monoxide. Okay, now have a look at this spectrochemical series and try to find out the correct answer from the given options. Here we can see in the first option, we can see that cyanide is written before C2O4 2 minus, but here in this series you can see the C2H4 2 minus comes before the cyanide. Okay, so this is not the correct answer. Now in the second one we can see that SCN is written after fluoride. Okay, so this is also not true because SCN here in spectrochemical series comes first and then fluoride comes. Okay, so this is also not true. Now if we come to the third one, then cyanide, then C2O4 2 minus. So again cyanide comes later. Okay, and C2H4 2 minus comes first. So this is also not correct. Now in the last one we can see SCN minus, that means thiocyanide. Yes, this comes first. Then fluoride. Yes, second is fluoride. Then C2H4 2 minus. Okay, this is also correct. And then Cn minus. Yes. So this is a correct sequence. So option D will be the correct answer. Okay. Okay, now question number 82 is from the chapter polymers, and the question is, which of the following is a natural polymer? Okay, option A is polybutadiene styrene, then option B is polybutadiene, option C polybutadiene acrylonitrile, and then the last one is cis-1,4 polyisoprene. Okay, so the correct option is option D, that is cis-1,4 polyisoprene, and this is nothing but natural rubber. Okay, and what is the monomer of this? Isoprene. Okay, so it is the polymer of isoprene. What is isoprene? It is 2-methyl 1,3-butadiene. Okay, now let's draw the structure of natural rubber. It looks something like this: carbon carbon double bond, this side CH3, this side CH2. The bond will continue this side, bond formation. Here hydrogen, here CH2, then this CH2 will be connected to another isoprene, carbon carbon double bond, then this side CH3, CH2, it will form bond, then hydrogen. Okay, Alright, now question number 83 is from the chapter Chemical Bonding and Molecular Structure, and the question is which of the following set of molecules will have zero dipole moment. So which type of molecules have zero dipole moment? Symmetrical molecules. Okay. Now let's check one by one. We come to the first option. Here boron trifluoride is the first molecule. So let's write the structure of boron trifluoride. So this is the structure of boron trifluoride. 3 fluorine atoms are there and the direction of dipole moment will be towards the more electronegative atom. So here fluorine is more electronegative than boron. So the direction will be like this. Okay. Similarly here like this. Got it? Now the dipole moment on the lower side will be cancelled out by the dipole moment on the upper side of this line. Okay, so here the dipole moment will be 0. You can see that this is symmetrical molecule, right? So dipole moment is 0. Now we come to the second molecule mentioned. It is hydrogen fluoride. So if we draw the structure of hydrogen fluoride, then it is hydrogen and fluorine only. Okay, and fluorine is more electronegative, so the direction will be hydrogen to fluorine. Okay, so there is nothing to cancel this dipole moment, therefore here the dipole moment will not be equal to 0. Okay, so this option cannot be the correct answer because hydrogen fluoride does not have zero dipole moment. Okay, now we move to the second option. Here nitrogen trifluoride. So let's draw the structure of nitrogen trifluoride. N, and here all the fluorine atoms are on the lower side. Okay, so the direction will be like this. So this molecule is not symmetrical and there is no cancellation of dipole moment. So again dipole moment will not be equal to 0. Okay, so option B is also incorrect. Now we come to the third option. First is boron trifluoride. So we have already seen boron trifluoride. Here dipole moment is 0. Okay, so next move to the second, that is beryllium difluoride. So beryllium difluoride means beryllium atom, then 2 fluoride, 1 fluorine this side, 1 fluorine this side, and the direction will obviously towards the fluorine. So here, yes, this is a symmetrical molecule. So the dipole moment will be 0 because dipole moment on one side is cancelled by the other side. Okay, so this is also 0 dipole moment. Now the third one is carbon dioxide. So again this is a linear molecule, carbon this side, double bond O, double bond O. So this is also symmetrical, you can see. Okay, and oxygen is more electronegative, so the direction will be like this. Again symmetrical and cancellation of dipole moment, so dipole moment will be 0. Okay, now the last one is 1,4-dichlorobenzene. So let's draw here. This is benzene and 1,4-dichloro. That means this is first position, 1 chlorine this side and 1 chlorine this side at fourth position. Direction will be towards the chlorine. Again, this is a symmetrical molecule, so dipole moment will be 0. That means yes, all the options, that means all the molecules mentioned in option C have 0 dipole moment. So option C will be the correct answer. Got it? Okay, now question number 84 is from the chapter Equilibrium, and the question is HCl was passed through a solution of calcium chloride, magnesium chloride and sodium chloride. Which of the following compound or compounds crystallize? Okay, so the fact is quite simple that calcium chloride and magnesium chloride are more soluble than NaCl. Okay, more soluble than sodium chloride, and due to this they will remain in the solution while NaCl will precipitate out. Okay, so what happens when HCl is added? Cl is added to the given solution. The concentration of chloride ion will increase. Okay, due to this the ionic product of NaCl will become more than the solubility product, right? Ionic product of Na plus Cl minus will become more than the solubility product of NaCl. Okay, so NaCl will precipitate out and Other chlorides, that means calcium chloride and magnesium chloride, being more soluble will remain in the solution. So only NaCl will precipitate out. So option A will be the correct answer. Question number 85 is from the chapter Environmental Chemistry, and the question is, which of the following is not correct about carbon monoxide, that is CO. Okay, so the first statement is it reduces oxygen carrying ability of blood. So this is a correct statement because we know that oxygen needs to bind with hemoglobin present in our blood to get transported from tissues to lungs. Okay, but when carbon monoxide gets added to hemoglobin, then oxygen cannot bind to it. Therefore, it reduces oxygen carrying ability of blood. Okay. Now, the next statement is the carboxyhemoglobin, that is hemoglobin bound to carbon monoxide, is less stable than oxyhemoglobin. This is not a correct statement because carboxyhemoglobin is about 300 times more stable than oxyhemoglobin. Okay. So 300 times more stable. So we have already got our incorrect statement. Still, let's go through other options as well. The third one is it is produced due to incomplete combustion. So this is the correct statement. Okay. Due to lack of oxygen supply, carbon monoxide is produced. Okay. Now the last statement says it forms carboxyhemoglobin. So we know that it is already given in the question, hemoglobin bound to carbon monoxide is carboxyhemoglobin. Okay. So this is also a correct statement. Only incorrect statement is statement B. So option B is the correct answer. Question number 86 is from the chapter Alcohols, Phenols and Ethers, and the question is anisole on cleavage with hydrogen iodide gives. So what is anisole? It is methoxybenzene. So this is the benzene ring and this is methoxy group, that means OCH3. Okay, and it has to react with hydrogen iodide, and we know that iodine is more electronegative than hydrogen, so it will acquire a partial negative charge, whereas hydrogen will acquire a partial positive charge. Okay, and in this anisole, oxygen will have lone pairs of electrons which will behave like negative charge, isn't it? So this positive part of hydrogen iodide, that is hydrogen, will attack the negative part of the methoxybenzene, that is oxygen. So what will be formed? Let's see. This is the benzene ring. This side we have OCH3 and hydrogen will also get added to oxygen. So OH, and the hydrogen will bear a positive charge. So in order to neutralize this charge, this methyl group has to leave the oxygen. That means this bond will be cleaved. So that the electrons involved in this bond will move to oxygen and neutralize the charge. Okay. So where will this methyl group go? We know that from hydrogen iodide, hydrogen has moved to anisole. So iodide is already left here. So iodide is there. So methyl group will move to this iodide. Okay. And then this will follow SN2 mechanism. And what will we get? This side we have an oxygen and a hydrogen. And methyl group has moved to iodide, making methyl iodide. Okay, so phenol and methyl iodide are the products. So which option is correct? Last option. Can you see this is the same product? So option D is the correct answer. Alright, now question number 87 is from the chapter amines, and the question is which of the following amine will give the carbylamine test? Okay, so what is carbylamine test? In this test, aliphatic and aromatic primary amines are heated with chloroform and ethanolic potassium hydroxide. Okay, so they form isocyanide or carbylamines. So let's write the reaction here. We have a primary amine. It can be aliphatic or it can be aromatic. Okay, and it has to react with chloroform CHCl3 plus ethanolic potassium hydroxide. Then what will we get on heating this? We'll get isocyanide, that is carbylamine, plus potassium chloride will be formed and hydrogen water will be formed. Okay, so what is to be noted here is that only primary amine gives the carbylamine test. Okay, so only 1 degree amine can give the carbyl amine test. Okay, so secondary or tertiary amine will not give carbylamine test. Now out of the given options we can see that only option D has a primary amine. Okay, so option D will be the correct answer here. Question number 88 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is reaction between acetone and methyl magnesium chloride followed by hydrolysis will give. So there are two steps. In the first step, acetone will react with methyl magnesium chloride, and in the second step hydrolysis will be done, right? So we know that methyl magnesium chloride is CH3 Mg Cl, that is known as Grignard reagent. Okay, methyl magnesium halide is Grignard reagent. So let's write the reaction here. First we have an acetone, so CH3 C double bond O and one more CH3, this is acetone. Now it will react with Grignard reagent, that is CH3 MgCl. Now we know that magnesium is more electropositive than methyl group than carbon. So this part will be positively charged, okay, because magnesium will acquire a partial positive charge, whereas carbon will acquire a partial negative charge. So methyl group will be the negative part of Grignard reagent. Okay. Now in this acetone molecule, what will be the positive part? Carbon will be the positive part because oxygen is more electronegative, so it will acquire a partial negative charge, so automatically carbon will have positive part. Now in this reaction, the negative part of the Grignard reagent will attack the positive part of acetone, and the positive part of Grignard reagent will attack the negative part of acetone. Okay, so methyl group is negative, so where will it attack? It will attack on the positively charged carbon, whereas magnesium is positive, so this will attack on the negatively charged oxygen. Got it? So what will be formed here? Carbon, CH3, CH3 was already there, one more CH3 will be added here, okay, because methyl group has attacked on this carbon. Now here we had an oxygen earlier, and what will be added to this oxygen? Magnesium chloride will be added. Okay, while oxygen has negative charge whereas magnesium has positive charge. Now this is the first step. Now in the second step, hydrolysis is done. So what will happen? This magnesium chloride will be replaced by hydrogen. Okay, so carbon, CH3 here, one CH3 this side and one more CH3 this side, and this side we have OH. Okay, so hydrogen has replaced magnesium chloride. So what we have got, this is an alcohol because OH is there and three methyl groups are added, so this is a tertiary alcohol. Okay, 3-degree alcohol is formed. So 4 carbons are there, that means this is tertiary butyl alcohol. So option B will be the correct answer. Question number 89 is from the chapter Electrochemistry, and the question is on electrolysis of dilute sulfuric acid using platinum electrode, the product obtained at anode will be. Okay, so when platinum electrode is used, what will happen? First, the sulfuric acid will be dissociated. H2SO4 will get dissociated to give hydrogen ion plus sulfate ion. Okay, now water will also be dissociated, so H2O will be dissociated to give H plus and OH minus ions, right? Now what will happen at different electrodes? First at anode, what will happen? OH minus will be oxidized because at anode oxidation takes place, right? Oxidation takes place at the anode, so OH minus ion will get oxidized to give H2O plus oxygen gas. Okay, plus it will also lose electrons. Okay, so on balancing this we can add 2 here and 4 this side. Okay, so this is a balanced reaction for the oxidation at anode. Okay, similarly we know that at cathode what takes place? Reduction takes place. So here what will be reduced? H plus will be reduced. 2H plus plus electron. So it will gain electron to get reduced into hydrogen gas. Okay. So what have we obtained at anode? Oxygen gas is obtained, right? So option A will be the correct answer. And the last question is from the chapter Chemistry in Everyday Life. And the question is, which of the following is a cationic detergent? Options are sodium stearate, cetyl trimethyl ammonium bromide, sodium dodecyl benzene sulfonate, and sodium lauryl sulfate. So this is a direct theoretical question. We know that cationic detergents are long chain cations that are responsible for surface active properties, right? And cetyl trimethyl ammonium bromide is an example of cationic detergent. So option B is the correct answer. Okay. Now let's have a look at the structure of cetyl trimethyl ammonium bromide. First we have a methyl group, then 15 times CH2, so CH2 15, then a nitrogen having a positive charge, then 3 methyl groups added to this, CH3, CH3, CH3. Therefore, it is cetyl trimethyl ammonium bromide. So, one bromide ion is also there. Okay. So, here we complete all the chemistry questions from this paper. I hope the session was helpful to you. Keep learning, keep scoring high. For any doubt related to papers, join our Telegram channel. Link is given in description. Also, do subscribe our YouTube channel for more such informative videos. Thank you.